It was a nice sunny day yesterday, very comfortable. Hope you got to enjoy it. It was really nice conditions despite that breeze, and we have a high pressure system continuing to move through, but despite that, seeing a bit of rain pushing its way into the Northland as we go into this morning. Right now, most of it is to the south, but as we get into the evening hours, we'll continue to see some showers sticking around here in the Northland, especially south of Highway 2. Continue to see cloud cover as well. And as I mentioned, this is in spite of a high pressure system, and it really is. By the time we get to the evening where we expect most of the rain to come in, the high pressure system is actually going to be situated right over the Northland. And you might be wondering, why is this the case? It is such a strange anomaly. We talk about high pressure systems being associated with dry conditions. Most of the time it is. In fact, probably 90–95% of the time it is. But here's a case where we could still see rain under a high pressure system. And to understand that, we're first going to delve into understand what potential temperature is. What that means is basically you take some air higher in the atmosphere, a parcel of air, and you bring it on down towards the surface, around the surface. And then it gives you what would that temperature of that air parcel be then, because as you pull air higher in the atmosphere down, it actually warms. So what is the potential temperature it could be? Now, this is an unusual concept if you think about it, but it is a very important concept for a lot of thermodynamics we use in meteorology. Now, the thing you want to really know is we're going to assume that air is what we call isentropic. Basically, that means it stays at a level of constant entropy. It does not exchange energy with the environment. And when it is isentropic, which we assume for air on larger patterns, we can assume that, then what it does is it follows planes of constant potential temperature. This is called isentropes. And I want to show these lines of isentropes right here. So these lines right here are lines of constant potential temperature, as I talked about. Again, they're called isentropes. And now we have an air parcel here. So when we assume the air is isentropic for large scale flow that we do, it will follow these isentropes. So there's the air parcel will flow down with it. And as the isentropes, if they move up in the atmosphere, then the air parcel will follow it. But notice this, when air moves up, as we know, especially if it has plenty of moisture, then it will rain out. That's the instability. That's why air that moves up in the atmosphere is unstable. Then here we can see one, going to rain out. So we're now looking at a scenario here. We're going to look at a low pressure system. So we have our air, and it's going to move in, and you'll notice it goes, follows these isentropes, and that means it moves up, it ascends. And that ascending motion means there's instability, and it can potentially rain out if the conditions are right. High pressure system, this is what it looks like. This is what the isentropes will look like. Notice it's the opposite effect, especially near the surface. We actually have that descent right there, which means there's more stable conditions as you move towards the high pressure system. But that makes sense. Of course, we could kind of rationalize all of this now using isotropes to understand it. Low pressure system, more unstable. That's why when we have a low pressure system move through, we get that rain. And the opposite, when we have a high pressure system, because of that isentropic descent that we showed you there, that's why we see stable conditions, sunshine. But why aren't we seeing it today? You'd think so with a high pressure system. And to an extent, there is a bit of stability. Look at here. In this case, I'm showing here, we have still some descent here, especially near the surface as we approach the high pressure system. So in that case, we should be seeing the sun. But it's not always the case. We have to look a little higher up in the atmosphere into the mid-levels. And we look higher up. When we have an influx of warm, moist air into the mid-levels, look at that. You still see a little bit of isentropic ascent. So even when there's a surface high pressure system, can still see a little bit instability, a little bit higher up in the atmosphere as we're seeing today. And here it is. We're looking at the mid-levels. We're looking at the temperatures. Notice, pretty cool, around freezing higher in the atmosphere, but we're going to have this warm, moist air is going to try to inflow in, even though we have a high pressure system, and move in, especially as we start heading this evening into the overnight hours.